Okay, hello everyone. Good afternoon, good morning, and good evening, depending on where you're viewing this from, and a very warm welcome to everyone that's joining us for this session today, which is brought to you by eldoLED, Pharos Architectural Controls in association with Arc Magazine. My name is Matt Waring, I'm the editor at Arc Magazine, and I'll be moderating proceedings for today's session, which is entitled Maximising Your Quality of Light with DMX. So shortly, I'll hand you over to our hosts for the session, which are Stefan Weideven of eldoLED and Bas Hogsbergen of Pharos Architectural Controls, who will take you through the world of lighting controls, breaking down the basics of DMX and its various applications from theatre to architectural lighting, before explaining how it can be used to maximise the quality of light. We'll then close with a Q&A session where you can send your questions over for Stefan and Bas. You can submit these at any time using the Q&A box. So please don't be shy and get your questions in. So without further ado, let's get things started. Let's get things rolling. So to do this, I'll hand you over to Stefan and Bas. So take it away, guys.
Thanks, Matt. Thanks for introducing us. My name's Stefan Weideven. I'm working for eldoLED as Technical Sales Manager. Today we're going to walk you through the presentation that we prepared together with Pharos Controls called Maximizing Your Quality of Light with DMX. Short introduction, who's eldoLED? We as eldoLED are recognized from our LED drivers, which are already in the industry for more than 15 years. One of our most recognized products is our power drive and linear drive products, which are controlled through DMX. That's what we're going to touch on today. Our technology, which we use in our drivers, brings the maximum performance from a light output perspective and from an industry standard DMX type of controls. Pharos is helping us out in bringing that control solutions. So moving to Bas.
Thank you, Stefan. First of all, thank you for bringing us to this webinar. My name is Bas Hogsbergen. I'm working for Pharos Controls, and I'd like to welcome you all on this 22nd of February 2022, which is a Tuesday, or better known as a Tuesday. Pharos Controls has been making DMX controllers for the themed entertainment for over 15 years, and our first controllers were really aiming at these highly specialized themed entertainment, but soon people started to realize that the performance and the reliability of our DMX controllers is extremely suitable for architectural installations as well. And we'll be explaining you some technical features about using DMX today.
Exactly. Quickly looking into the agenda of today, we're probably having roughly a 25 to 30 minutes presentations. We start with the world of lighting controls. We're touching a little bit on the general DMX basics, and on that point on, we move from theater to architectural type of projects. We're explaining how to achieve that maximizing quality of light, and we're ending up with the key takeaways of this presentation, and then we're open for questions as well. So moving to the world of lighting controls, I only want to touch this real short because we're only zooming into the DMX part, but next to DMX we have DALI and we have 0 to 10 volt type of control solutions, mainly in Europe, and all the brands you see around those industry standards are all working together based on those DMX, DALI and 0 to 10 volt standard. So however we all have our own customers, we're joined together based on the protocol standards where we're highlighting on DMX today. From a lighting control perspective, you probably have seen this slide many times within eldoLED, but we like to touch base on the fact that we as an LED driver manufacturer are making the current based on the control input that we receive from the dimmer or the controller, and that's a language, a set point. And if you compare 0 to 10 volt and DALI and DMX all together, you see that 0 to 10 volt is mainly a one-on-one. DALI is most of the times up to 64 control channels or 64 LED drivers. And DMX is one single universe, is already containing 512 channels, and the amount of universes can be way more than just one. So I've seen installations with 24, 25 universes, and they're probably not the biggest one out there in the market, Bas. So to you on the basics of DMX.
Great, and I will start simple, right? We indeed can go to thousands of universes, but let's talk about the basics here. The basics of a DMX installation is that you have one controller in the system that is sending out a DMX signal to up to 32 receivers on a single line. And this DMX cable is a special cable, right? You cannot use any cable. It needs dedicated wiring, and it's following what we call a bus topology. So it's a single line from the controller to the first, to the second, to the third receiver, etc. At the end, you need to add a little thing called the terminator. Why is that important? DMX, it's pretty straightforward, but you need to keep a few success factors in mind. The first one is to use suitable cable, to use correct topology, to terminate the line, and be sure you're dealing okay with isolation. When using quality equipment like eldoLED or Pharos, we've taken care of all the isolation for you, so you don't need to worry too much about that. If I quickly go into the DMX signal, it's actually quite interesting. Here we see the slide. There are up to 512 values that are being sent 33 times per second. So at quite a fast pace, all this data is being sent. And every channel can have a value between 0 and 100%, or 0 to 255. And actually those values don't mean anything. They can be anything. So how do you make sense to this, or how is it being used? That's actually coming part from the driver. Let's say you have a driver that is controlling RGB channels. It means most likely that driver has 3 address footprint, or it's using a footprint of 3, one for red, one for green, one for blue. And it also has a start address to know where in this line of DMX channels to look. So if I look to this example on the slide, this is a driver addressed at address number 1, looking to RGB, and because of that we know we use the first value, which is 100% for red, the second value, which is this case 128 for green, so this will create an orange color.
So this fixture is responding to those first 3 parts of the chain.
Exactly.
And what's happening with all the rest?
Well, the driver is just ignoring it, but of course you have a big chance that there's other drivers on the bus. For example, the second one that is looking to another part of that data set, and because of that is able to do another color. So it's because when you're programming the DMX controller and knowing what type of drivers you have on the network or on the DMX bus, is that we're able to control and send the relevant colors to all the relevant fixtures. And it's important to know that it does not need to be RGB. The DMX value can mean anything. So also whether it's just a white fixture or a tunable white fixture, the DMX values can be used to control any type of fixture. When we talk about quality of light, of course, there's also people who say, yeah, but maybe I don't need just RGB or RGBW, but I want to use multiple emitters. And that's all possible. On the drivers, you can connect any type of colors, emitters you want, any type of color LEDs. And if we're using a suitable control system, we can still take care that controlling color is as simple as putting a color picker, or if you want to, offer the freedom to control the individual emitters by themselves.
So we have an LED driver that's having 4 LED outputs, and we have versions with 3 outputs. We even have single channel versions. But what happens if I want to use 7 or 8 channels? From a color picker, I understand it, but how will that work from a driver perspective, Bas? Can you help me out there?
Of course, the benefit here is that, again, DMX, right, the values are not defined. So you can very conveniently put 2 drivers into a single fixture. And this one fixture can maybe exist of 7 emitters, right? Indigo, amber, lime, whatever colors you want. And within the controller, we can make a fixture profile, as it's called, and make sure that that fixture can just be controlled from the color picker. And we make sense, we send the relevant DMX values on all the relevant channels. And there, your drivers know to control the LEDs.
So in that fixture profile, we tell the controller which colors are actually existing in my luminaire.
Exactly.
And that brings up this control type from a control perspective. So it's very important that if you add those fixtures to your control system, that you correctly assign the colors to each individual channel in that case. And that's done with a fixture profile issue.
Correct. And of course, this is something where we help our customers with. This is not something the typical end customer needs to worry about, but we can make sure that these things are available. So it's easy to use. So why are people using DMX, right? The main benefits is because it's so fast, right? It's 33 times per second. It's sending all the data. It is very easy possible at any type of scale installation to make the lighting react in perfect synchronization. And those installations can be RGB, but as mentioned before, also tunable white or color. You have the benefit that all knowledge is inside the controller. So as long as the controller can output what you want, your lighting can do anything. You're not limited by any other protocol limitations. The other benefit is that when you design an installation and you're going for DMX, it's making your installation future-proof because all the intelligence is only at a central place. You can decide later on, if you need other fixtures or other functionalities, you can just change the controller, or maybe, and we'll show a project where that happened, maybe for a special event, you're temporarily using another control system to cater for entertainment purposes. Two downsides that people sometimes think exist, which are not necessarily the case. With DMX, there's an additional part of the standard called RDM, which is allowing a controller to talk to drivers or allow the drivers to talk back to the controllers. So it is possible to have bidirectional communication on RDM. And the other benefit, the other drawback to keep in mind is that because the values sent via DMX are stateless, something like a color temperature, that doesn't exist in DMX world. Of course, between the controller and a driver, we can agree on certain colors, but there's not no such a thing within the protocol.
So looking into a project example, we've equipped the dome tower with one of our customers, ProLED Lighting in this case. They've equipped the dome tower with our power drive products to control all the tunable white and single color luminaires on the outside of the dome tower. And that's controlled through Pharos. But in the end, if I walk through Utrecht, I only see the tower static illuminated in most of the times. But in special occasions, they can change it in such a way that every individual luminaire can be controlled in a different way. So however I'm seeing it as static lighting, it can be dynamic, it can be sometimes full color. However, the dome tower, as far as I know, is not equipped with RGBW luminaires, but it's mainly white and tunable. But it can be anything from fast flashing transitions to static lighting. Correct. Where in such a big project, I think the synchronization of the light is key, because you have hundreds of luminaires in that
indeed
in that project.
And DMX is a perfect choice for that.
The project I like. I mean, in France, we have Chateau de Versailles. We have a castle with 2,000 individual candles burning in front of the windows. Mm-hmm. That's all controlled through eldoLED PowerPix technology, controlled through DMX, and even the gardens, which is like a long pathway of luminaires and fountains and all that stuff. Every individual luminaire at Chateau de Versailles is DMX controlled. Most of the time, the castle is having a candle burning effect, which is controlled through the Pharos controller in this case, and the gardens are having static white applications. But as I've showed you before, and you can watch it on YouTube, Chateau de Versailles sometimes is changing the wall appearance into a very festival dynamic situation, and that's where they simply use the existing infrastructure, which is based on DMX, to hook up a different lighting controller to make complete different atmosphere in the project.
Exactly, as they did here for I think this was actually sometimes even techno event.
Yeah, it was
right. People come in with a live console and they can just plug it in and take over the DMX installation and use the benefit.
And how great it is that with simply plugging in a new lighting controller at that moment takes a few minutes. All of a sudden, you get a control over such a large space. Exactly. In the project that we did.
Correct.
Another interesting one, Bas?
Yeah, exactly. looking to time, I'm not sure if we maybe should go quicker, but also over here, I think actually here, the control system installed is a Pharos system installed by one of our partners. And I believe it's actually being used here to train students to learn how to use control systems in this particular project.
That's a nice example, Bas. Looking into the quality of light for humans, I mean, quality from a technical perspective, that's simply by using the right brands. And they know all the technical stuff, they hook it up together. But what about humans? I mean, for humans, it's very important to have a stable light output. And that's something we can only achieve by sticking to standards. And one of the standards in the flicker performance of an LED driver is called the IEEE P1789. And that is a standard that ensures that ensures you that the light you're using is safe to be used if you need to witness or experience the light. And in a lot of situations, it is not so relevant because you can easily avoid the light. But there are also a lot of applications like hospitals, classrooms, and so on, where you cannot avoid the light. And that's why adding on the quality of light is definitely one of the key elements there is flicker performance. And that's not so typical in entertainment and architectural type of lights, because everybody understands in DALI installations that is one of the key requirements. But people think that DMX is flashy in entertainment, but that's not always the case. And that's where the flicker performance of an LED driver comes in handy, next to the fact that most of the times those DMX type of projects also require camera compatibility. That's a question I get all over the place every month again, is like, is your LED driver usable for recordings? And that's something we do by making the light output, the modulation of the driver, synchronized with the frequency of the camera that is recording the environment. However, the camera is recording at a fairly low shutter speed, like 50 Hertz, 60 Hertz, sometimes a little bit different. The frequency of the modulation is much higher. We're stating here 1 kilohertz, but it can be up to 10 or 20 kilohertz in general. The only way we ensure ourselves is that the synchronization of the shutter of the camera is exactly in sync with the modulation of the driver algorithm. But then I hear that DMX is like 33 Hertz.
Exactly. If you go to the next slide, I mean, we as a control system sometimes get the questions, but is DMX refresh rate compatible with my camera? So we try to explain this in this simple graph, right? This is only a tenth of a second that is shown here. So this is an extremely short portion. And a DMX frame is sent every 30 milliseconds. And, you know, that's roughly the same as the camera in that direction. And that has no influence in terms of camera compatibility, because the flicker on the camera comes from how fast the driver is going. And this illustration, I think, as you mentioned, right, in reality, it's about 300 times between two DMX frames that your driver is actually controlling the light.
Yeah, and that's what we need to have that smooth dimming perception as well, because if the frequency is not high enough, there are not enough steps to make it smooth. But there is no link between the DMX frequency and the light output. So whatever DMX frequency we're using, it can be completely different from the light output. Another interesting project.
Yeah, I think this is an interesting one, right? Because what you just highlight, that the quality of light for the human being, right, where they cannot go away. This is in a hospital, and in this hospital, they are using eldoLED drivers and they're using Pharos controls. So they are using DMX here. And I think you just explained why, you know, people like to use eldoLED, because flicker safe for people. But it's also in this hospital, people went for DMX because it offered the company who made this project, Chroma Viso, to give the full flexibility to make the lighting do exactly what they wanted at the moment they wanted to do. And they used the freedom in the Pharos controller to program their light recipes, which in their case is really a study that has been medically proven, how to control the light in such a way that it makes, well, contributes to the health of the people within the hospital.
Yeah, and next to the fact, it also helps the surgeries to have a better view on the monitors during the surgeries as well, by changing the lighting atmosphere in such a way that the contrast ratio between the screens and the ambient lighting is optimized in such a way that they can easily see the details they need to see on the patient monitors. So interesting project, by the way.
And now we want to explain a little bit more about the technicals of it, because people might have heard about the word resolution or dimming curves, and we want to use the remainder of this webinar to go in a bit more depth about that. And to start with the first part, resolution. Resolution is nothing different than the ratio between the input and the output. DMX is a digital signal. I mean, LEDs are to some extent digital. So there's always a relation between an input and an output signal. And how many steps we use to describe that relation from input to output, that can be 8-bit, only 255 steps, 16-bit, over 16,000 steps, or even 24 bits. And in this part, it's interesting to understand that a DMX controller towards a driver, they talk only in 8 bits, right? We mentioned the intensity for a certain channel in 8-bit, sometimes in 16-bit for certain installations, but that's where it ends for the controller. But I understand in the driver, you're actually using 24-bit.
Yeah, in the drivers, we go up to 24-bit to ensure ourselves that with every step we take from an intensity perspective, so step 1 on DMX to step 2, that it's not a simple step, but that we can create a smooth transition from that single intensity set point to that next step, basically. Yeah. And that goes all the way up to 24-bit, and that gives you more than 16 million different steps between 0 and 100% light output.
Yeah, and let me try to explain the second thing, and I'm sure we'll get back to what you just mentioned. The second concept is from a dimming curve, right? That's the relation between an input value and the output value. We have this resolution, but of course I can say the same input should result in the same output. But it's also possible that you want to make that happen via a different curve. And why is that relevant? If we go to the next slide, we can see that I'm actually going to take this slide from the right to the left, right? If we want to have a perceived light output, let's say for a theater or something like that, we of course want to be sure that the dimming is very linear, right? That
we expect that it goes smooth without having steps and bumps and all that stuff.
Exactly.
And that's why we need that linear perception of the light.
Correct. So we see that on the output.
We see here.
But to get there, we need to remind ourselves that the human eye is, of course, not working linear, as we can see in the graph. And in order to deal with this, there's actually quite a simple way to do this. The right drivers have the ability, and the right controls as well, to set a dimming curve. And if you're using a logarithmic dimming curve within your driver, or within the controller for that matter, you can make sure that if you're setting the light to 50%, the rest of the process is just working out to make sure you get a nice linear transition of the light, or a linear curve of the light.
So if your controller says I'm in 50% of the value, my perception in the end is 50% of the light level, the brightness.
Correct.
And that doesn't necessarily mean 50% of the energy usage, or 50% of the lumens or the flux that we have on the table. It's just to match that perception from a control perspective all the way to the human eye.
Exactly.
And that's important, especially what you mentioned in the theaters, where we have the Shoot or Shoot project of a college, where you have that perception that when they turn on the lights, you hardly notice the moment that the light turns on.
Correct.
And even when the lights start dimming, you're not realizing that last step from I still have light until there is no light anymore. We assume it is very easy, but practically that isn't that easy at all, right?
Yeah. And it's interesting because when I showed you the dimmer curves before, when it comes to color, of course, something else comes at play, because when you're creating color, the eye is still very sensitive to slight changes for different colors. So in that case, typically, the most important part is to set the relevant color. So that might mean you want to use the linear curve in both the controller as well in the driver. But then you might ask, okay, but if I'm using color system and I want to go for linear curves, how can I then be sure that the lights are fading out smooth in what I perceive as a linear fashion? And we can still do that because good control systems also have a way to set what we call a fading curve. So if I go from one intensity value to another intensity value, let's say I want to fade out in 2 seconds, I can go in there in a linear fashion, but I can also go there with a smooth curve. And that is allowing us, if we look on the next step, to make sure that during a fade, we can use a different transition curve. For color pictures, this can be a convenient situation. That I am using the linear settings in my controller and my driver to have the best granularity of setting controls. But for the fades, I give a transition along a certain curve to be sure that the perceived fading out of the lights is happening in a linear fashion.
And that gives you the flexibility and freedom to reduce the brightness in a different way than moving from one color to another, right? That's the purpose, right? Because the driver in general only has a dimming curve, but your control system gives you the flexibility to do something different on intensity than you would do on a color transition.
Exactly. For the fades, you can define the behavior you want.
Looking into those frames, I mean, we're moving from one set point to another with that fading curve. But in a typical DMX, if you go from one set point to another, it's a step, and that might give you some steppy results. That's where we as eldoLED come in with the resolution we have in our LED driver, that we can add a slight amount of interpolation to calculate those in-between steps between each frame. So each frame that is bringing you a next set point, sometimes it's the same, but it can be a complete different set point. If we see that transition and we see the step, we calculate the steps in between in such a way that we perceive it as smooth. And that can be set into multiple different values from off all the way to glow. And the only thing that's changing is how that corner is adjusted in such a way that we perceive it as smooth.
And I think going back to the example from the theater, right? In DMX, let's say you have a controller that's set to 8-bit. I can send you 0 or 1. There's nothing in between.
And that's a huge step.
Exactly. If I understand you correct, you are making sure that between this, it's still going smooth and the people don't, the light goes on, but they don't actually perceive that it started.
Actually, exactly like that. And we also do that via a different curve. More or less similar to
but at a much smaller frame.
But the transitions into detail from an LED driver to an LED driver perspective.
I think that brings us to the end of this presentation. Time flies.
It goes quick, right?
Exactly.
But that's always when you're having fun.
Yeah.
The key takeaways of today, boss. From an LED driver, I think it easy. You need to have an LED driver with sufficient resolution to suit your needs, and it needs to have great refresh rates. So it needs to be able to respond quick, and it needs to have an accurate LED output. So why do we offer dimming curves? Because you can do it as well. You have even more dimming curves than we have in our drivers. It's simple because of the fact that not every eldoLED driver is used with a Pharos controller. And some controllers doesn't offer you the flexibility of creating a dimming curve. Next to the fact, from a controller perspective, boss, how would that look?
Well, the benefits
benefits from the control perspective. So I can change my dimming curve, you can change my dimming curve, and we both know together what is the best combination.
Depending on the project, people will know what to use. And also this is maybe, I'm jumping to the end, but a great way of doing your projects with Pharos and with eldoLED components will be sure you always have the support you need. The points I still like to raise why I think it's good to use the Pharos controller. Controllers with consistent during DMX output, so also during fades, is quite important, right? The other point is that set dimmer curves, as you mentioned, it's quite convenient. Yes, maximizing the quality, I guess the bottom line is be sure you use components from respected brands that follow the standard, give you the tools to give all the results that you need for your project.
Great. Moving to Matt, back to Matt for the Q&A, because there might be some questions popping in as well, right? Let's bring Matt on the screen again. Matt, are you there?
Yes, hello, hi. Sorry, I'm here. I was worried I was having some connection issues there, but thanks very much, Baz and Stefan, for that. Yeah, a really interesting presentation. It was a deep dive into DMX, which is exactly what we wanted. So, as you mentioned, yeah, we've got the Q&A session. So, obviously, inviting everyone to submit their questions to us, and we'll try and get through as many as we can in the time that we've got left. So, one of the questions that I wanted to ask personally, actually, is when you talk about all the capabilities of DMX control and the many different capabilities that you discussed there, is there an issue that it's maybe too complicated? Is it too complex?
No, I think DMX by its nature, it's just all pretty straightforward. You need to use the right components and that's it. That said, we do know that depending on the control system you use, can be pretty complicated to set up. And that's also why Pharos will, keep an eye on our website. We will shortly introduce a new control system that will be even easier to program.
Next to that, I only found out after 5 years of using Pharos that they have a great help feature in the application, bringing in on exact every individual setting, like a nice explanation how you want to achieve something. Because most of the time you start playing around without reading the manual. Yeah. And after a few years, you realize the manual is even the guideline to move you through the software. That's the takeaway that I got from the Pharos designer software. What else did we get in, Matt, from a question perspective?
Okay, so we've had another question. I suppose it's comparing DMX to DALI, which is kind of expected, I guess. But they've said that DALI is able to dim from 100% down to 0.1%. But the customer's not happy with that little jump that the luminaire does before it's going to 0. So with DMX, can you get that smooth transition all the way down to 0%?
From a driver perspective, it's equal. I mean, our output of the LED driver is not linked to the control input. So if your control input is 0 to 10, if your control input is DALI, or if your control input is DMX, the way we translate that control signal into output current is similar for each individual driver. So it's not that the DALI driver cannot dim lower or not dim the same than a DMX driver can do. However, if you use a linear dim curve and you have 255 steps available for dimming, that would mean that your first step is roughly 0.4%. In DALI, that dimming curve is in almost every application logarithmic, where that first set point is actually 0.1%. But I'm 100% sure that if you're using an eldoLED driver with a linear dim curve in 16-bit resolution and you use the correct curve on a Pharos control system, you can dim way below 0.1%.
Agree.
And then there is no visible step from that 0 to that first time to light, as we call that as well, Matt.
Okay. Fantastic. And we've had a question come through regarding dynamic lighting installations. They've said, I've been using Max MSP to generate content from video for my DMX lighting system. So can you elaborate on the capabilities of Pharos software for generating content for dynamic lighting installations?
I mean, within a Pharos control system, you have the freedom to use pre-built effects and apply that on groups or multiple groups or in various ways to get the visual result you want. But you can also simply load a video and play that back on an installation. So I'm not familiar with the software you just mentioned, but there are different ways how you can use a Pharos controller to get in video content and apply that on your installation.
Yeah, you guys even have Pharos controllers where you can enter a live video feed into the controller.
It's even possible to have live DVI.
Into DMX type of luminaire control data. Right?
Exactly.
Okay, excellent. And when we talk about the various control networks, how does the control network compare in price when you compare the 3 different types of luminaire control?
I think maybe the relevant point to mention here is that DMX cabling can just simply be Ethernet cable. Standard Cat5 cable or shielded Cat5 cable can be used to run a DMX network, and that cable is typically not very cost effective. It's very cost effective, not very expensive.
Sure. And in a 0 to 10 volt application, it's one control slider, one cable, 25 LED drivers, with just one single control.
Yeah.
With DALI at 64, But if we're talking about single color luminaires on one universe, we can add 512 individual channels.
Clear.
So 512 drivers, but you cannot connect 512 drivers to that single DMX cable, right?
Indeed. DMX,
That's limited to 32, but you can use splitters, boosters from different vendors. Pharos is offering them, Pathway Connectivity is offering them,
correct.
ETC is offering them. That's just DMX infrastructure.
Correct. And I think if you look at high level for the cost of the installation, a DMX signal itself, which means needs to be in a different circuit, DALI is mains rated and can follow a star typology. So sometimes for a retrofit installation, DALI can sometimes be more cost effective, but typically you see that the cost of the control protocol can be neglected compared to the cost of the rest of the system.
Okay, and we've had a few more questions coming through that are kind of comparisons between DMX and DALI, which I expected that we would. So someone has asked if DMX is more scalable than DALI.
Yes, and the reason why I say that, why I see a clear yes, the key thing to understand is that when you scale up the system, DMX is intended to stay extremely synchronized. So if you tell, lights go red now, even on, a thousands of universe DMX system, you can make sure that all the lights will react exactly the same. In a DALI system, of course, right, there are building-wide control systems, but those systems are not designed to stay in synchronization. So you can get these, what we call the popcorn effects, where just not everything is reacting at the same time.
Yeah, that's where we see that in a typical DALI installation, 1 second delay is accepted.
Yeah, correct.
In a DMX installation, 1 second is
it's always within the same frame.
You need to have it within the frames. So exactly at the millisecond, I would say almost synchronization. That's 1,000 times more synchronized than a typical DALI installation.
Correct.
And that's depending on the application, if that's a benefit.
Okay. And carrying on this theme, when we talk about lighting control systems and having these networks, obviously security is another big factor to consider. So how does DMX compare to DALI when it comes to, would you say it's more or less robust or safe than a DALI network?
Both protocols, DMX and DALI, are unprotected. It's just raw data. But from an infrastructure perspective, you can go from Ethernet to DMX, and on that Ethernet level, you can have several different protocols. You can have the ArtNet, you can have the ACN, you can have the secured ACN. There are multiple different protocols, and some of them even are secured in such a way that you cannot not easily hack into the lighting equipment.
Indeed. I mean, when we look to security, typically, let's say the last mile, right? So the actual DMX signal or the actual DALI signal, if people want to interfere with that, they can probably also cut the power and like that turn the lighting off. Security is, however, a very fair point, and we are doing a lot to make sure that the security of our controllers itself is very safe. And no matter if you want to control it only locally or via the internet, be sure that the relevant authentication is required and that security over there is well covered.
Okay. And so when it comes to, again, comparing DMX between DALI, when it comes to changing from one color to another, how does DMX compare on that front?
Well, in DALI, it's different from DMX, because in DALI, if you have one color in DALI color and you want to move to another color, the driver is taking care of that. And I can assure you, if you're using an eldoLED driver, that transition from one color to another color is going smooth, whatever DALI controller you're using. On the other end, from a DMX perspective, the DALI of the driver is simply listening to every individual control input. Then that transition is triggered by...
Because in DALI it's going smooth, but it's going along the pattern that you have defined in your device. And with the DMX control system, depending on the controller, we can offer you all the freedom to define how to fade from one color to another. Do you want to go there, in a direct line, or do you want to follow the U-curve when going there? Do you want to fade there, in a linear path, or do you maybe want to start slower and end slower? So, respecting the fading curves I talked about before. So with DMX, you just have more freedom to define how to make the transition from one color to the other.
And that requires the processing power, which is in the controller.
Correct.
And not in the driver.
Indeed.
Okay, cool. And one of the other questions we had was asking about the advantages of DMX compared to DALI. But I suppose the questions that we've just answered have kind of covered this. Would you say?
Yes.
Okay, so another question that we've had come through is regarding DMX wiring. They've said they heard that DMX wiring is easy and only requires 2 wires. Can you use any type of wire for this?
No, you should be using a what we call a twisted pair cable. And the reason for that is to be sure that even if you have external disturbances, and maybe we actually have a slide on that. Possibly.
Yeah, I'm not sure if it's
okay.
On the screen.
But to be sure that when there are external disturbances, don't really affect the signal. So you need to use dedicated cable, but as mentioned, standard Cat5 or shielded Cat5 Ethernet cable is allowed to be used. So it's not something tricky anymore.
There we have it. So you start with a DMX pulse, you make a balance signal. The disturbance you get on your cable is influencing both conductors, and the driver will subtract those two from each other, in the end getting your signal back. And it is not only 2 conductors, positive and negative, but you need to shield.
Exactly.
So I would say DMX is never 2 wire.
Correct.
DMX is 2 wires, including a shield or a ground reference, or 3 wires. Correct. But at least a twisted pair.
Shielded twisted pair is indeed the cable you need for DMX.
Okay, fantastic. And we've had a question regarding RDM. This was something that you talked about during the presentation. So how does RDM affect the frame rate of DMX? And then as a follow-on to that, how do you map a fairly random pattern of lights to be able to play a video over the top of it?
Let me answer the first question first. The RDM messages are in between DMX messages. When you're sending the DMX data and then you're sending the next frame, there is actually some time in between to send some additional data. So as long as you're using quality components, you will not be able to see in your DMX installation that RDM data is being transmitted back from the driver to the controller. And the other question, can you repeat that, please?
It was, how do you map a fairly random pattern of lights to be able to play video over it?
I'm happy to explain it, but I think that's a bit tricky without using the control software. So maybe we can get the contact details and get back after the meeting. But this is all done within the controller software, and I think that's a bit out of the scope of.
You simply bash at pharoscontrols.com, right?
Exactly. -h@pharoscontrols.com, or just more general support@pharoscontrols.com. We'll be able to explain you this.
Okay, fantastic. And we've had a question come through. Are DMX eldoLED drivers suitable to be installed in an outdoor luminaires, or they need to be remotely installed for an indoor location?
No, the eldoLED drivers are not necessarily designed for outdoor use because they're not waterproof. But most of the fixtures are designed to be waterproof. So if the fixture is waterproof, the LED driver is having a typical input protection of 2 kilovolts, which is not sufficient for lighting strikes. Then you need an additional surge protector on the line. Next to that, the control input is fully isolated, and that helps you in outdoor applications where you most of the times have longer cable runs and more influence on external disturbances. So yes, the driver, however, is designed to be an IP20 indoor driver, can definitely be used in outdoor applications. And I think, to be honest, the majority of the eldoLED DMX drivers are used in architectural outdoor projects.
Yeah, we saw that from some of the amazing examples throughout the presentation as well.
That explained.
Yeah. So we've had a question here for you, Bas. Does the Pharos controller have built-in capabilities to help with troubleshooting?
Yeah, definitely. We, especially our log, which is telling you exactly what's happening, but also you can see the status. I mean, the Pharos is a pretty advanced controller, and doing troubleshooting on a Pharos controller is pretty convenient because it's telling you exactly what it's doing. Also here, this might be a bit outside the scope, but if you would like to know more on this, contact us via support@pharoscontrols.com. We're happy to explain you more.
Okay, no problem. And we've had a comment here. I think it's in response to one of the earlier questions where they said they use a Pharos VDC to take video input and then output it as a control signal to feed the controller. I suppose that kind of covers.
Yeah, that's exactly what mentioned, right? We can take an incoming signal, and that's actually possible in both VLC, the Pharos VLC or VLC Plus range, as well as the larger 19-inch controllers, to take in a DVI feed and map that towards an array of fixtures.
Yeah, absolutely. They've mentioned that they've used it in application on Manchester Airport, and I remember that project, and it's a particularly, it's an amazing project with some great dynamic lighting. So we've got another question asking if you could briefly explain DMX in ArtNet, please.
Yeah, you should be able to do it.
I can do it very simple. Yeah. What I mentioned, DMX is a signal, right? 512 bytes of data. That's typically going on a physical DMX line. But it's also possible to send one or multiple of these, what we call universes, via an Ethernet cable. In order to do that, you of course need to have a controller that can output DMX over Ethernet, that we can. But in order to, in the end, convert that back from Ethernet to something that you can connect to a DMX driver, you need a converter. Pharos has these converters in their portfolio, but there's also other converters on the market.
The pathway ones that we have in our portfolio.
Exactly, to achieve this. We might actually maybe make a webinar later on, which will focus more on distributing DMX across a larger network. But I think to talk about it is a...
and ArtNet is just one of the protocols you're using over that cable, right?
You mentioned some before, right? ArtNet or ACN or secure ACN. There's multiple flavors available.
Okay, great. And we've had another question come through. We've got so many questions through, which is great to see. Excellent. And there was one question that I wanted to ask you guys. When you talked in the presentation, you mentioned about being studio cameras being a real consideration for you and ensuring that you don't get that flickering effect. But to what extent does that go down to phone cameras, I guess? Because when you look at, particularly when it comes to dynamic building facades, everyone's looking for, you know, the next Instagram picture and whatnot. So is that something that you have to factor in?
Yeah, you definitely have to factor that in, but there is a huge difference between a studio camera and a cell phone camera, because a studio camera is always operating at a fixed frequency.
Okay.
And the amount of light that the camera is receiving is adjusted with a physical shutter in the camera. A cell phone camera is using its variable frequency of the camera to reduce the light level. And what you see is that typical cell phone camera manufacturers are adding interpolation in the video screen, are doing everything to get that smooth and clear picture. And that's probably also the differences why you see phones with high-end cameras costing €1,000 and why you have cheaper phones as well. That's the quality of the sensor in the camera of the phone. Okay. That has nothing to do with the camera compatibility that we do on our end. However, because of the fact that we're using such a high frequency, it's most of the times compatible with the cameras out there in the market.
Sure. And another thing that I was curious about, when you talked about moving from theatrical to architectural lighting, and Baz, I know Pharos did a lot in entertainment lighting as well. Is this still considered to be quite a big transition, or do you think because architectural lighting is becoming a lot more dynamic and theatrical, is it easier for you to kind of work across both areas?
I think the big difference here is that a typical show is lasting, you know, a day or 2 days, and at the start of the day, the controller is started up and everything is started up for that evening and shut down afterwards. With the move from show control to architecture or architainment, these controllers need to be 24/7 reliable. And that's, I think, the biggest difference between those markets, right? It's not necessarily, well, on one side, of course, you don't have an operator, right? If you have a theater or a show, there's somebody pushing the buttons and controlling the faders to make the light show. For architecture, you typically want to have that all well defined within the box and just repeat it day after day. And on the other side, it's the reliability. You don't have a skilled operator on site on every DMX installation. So once it's up and running, it should just be reliable for years to come. and do the things it should be doing.
But that's where the remote diagnostics and the remote show update and so on comes in handy, right? You don't want to go to see all those places.
It depends.
It's just updating.
It depends on the project, how people are using it. Sometimes it's indeed install and forget, and it's installed and it's really left alone for, I don't know, 5, 6, 7, 10 years on end. And sometimes people want to have the flexibility to remotely log in and say, tonight the light should go blue, and I haven't programmed that yet, and program that override. All is possible.
Okay, fantastic. Well, I think that about wraps up all the questions that we had today. So thank you so much to everyone for sending in your questions. It's been a really great Q&A session off the back of a really interesting presentation. So thanks very much for all of your questions, and thanks everyone for tuning in. And then obviously huge thanks to Stefano and Bas for a fantastic presentation.
Thank you, Matt, for hosting us.
No problem.
Bye-bye.